All right, everyone. Welcome back to another episode of Bell Curve. Before we jump in, quick disclaimer. The views expressed by my co-host today are their personal views, and they do not represent the views of any organization with which the co-hosts are associated with. Nothing in the episode is construed or relied upon as financial, technical, tax, legal, or other advice. You know the deal. Now, let's jump into the episode.
Jimi Hendrix doesn't have to build his own guitar in order to write his own album, right? And I think I kind of want to borrow that to explain sort of what Celestia does, right? It's like, if I'm an app chain builder, what I should care about is my application. And I shouldn't have to worry about all the other layers of infrastructure.
All right, guys, welcome back to another episode of Bell Curve. How you doing, Miles?
Doing great, sir. How are you doing?
Doing very well. I'm excited for this episode. We've got Dave Ojha from Osmosis, Sonny's partner, who was in our first episode of the season. And then we've also got Nick White, who's the COO at Celestia. Can you give listeners, Miles, a little bit of a sense of why we've invited these two guys on?
Yeah, absolutely. So throughout the season, we've been talking about the definition of an app chain as an app, any sort of blockchain that dedicates its space to one specific application. And we've kind of teased this out, but there are multiple flavors of blockchains or app-specific blockchains. Anything from a full stack app-specific blockchain to an app-specific roll-up on Ethereum. And in the middle, you have the emergence of a new architecture known as a modular stack, right? And so there are lots of different ways to build app-specific roll-ups on the modular stack, which Celestia is enabling. And I think today we just want to tease out some of the trade-offs that builders should be thinking about when deciding between, should I take on all of the effort of a full stack app-specific blockchain because the benefits are worth it, versus, a more lightweight approach, which is building a roll-up on Celestia. So yeah, really excited to dig into it with them. I think these are two of the leading thinkers in the space as it relates to this stuff. And yeah, we've got a lot to unpack with them.
We do, certainly. It was a great episode. So guys, hope you enjoy it. Let's get right into it.
All right, everyone. Welcome to another episode of Bell Curve. Today, I'm very excited to be joined by my co-host, Miles O'Neill. And we've got Dave Ojha of Osmosis and Nick White, who's the COO at Celestia. Fellas, welcome to the show.
Thanks for having us.
Stoked to be here.
This is going to be a really fun one. I think we're going to have a little fun diving into the weeds on this. So thus far in the series, you've sort of defined Appchains as sort of app-specific block space. And each of the two of you have a very different approach to kind of the architecture that supports that app space. So maybe I could just call on each of you, listeners will probably be familiar with both your projects. And Dave, I know your co-founder, Sonny, was on our first episode. But can you just give a quick intro, just like define yourself and like your sort of approach and the project that you're working on?
So I'm Dave. Hello all. I work on Osmosis. The idea is it's a app chain that's basically doing the functionality of a DEX. So the idea of being an app chain is we can change things about consensus or how we execute things in order to give ideal guarantees for a DEX in a way that you probably can't for a generic execution engine. So like you can change, we can change things to add censorship guarantees or ordering guarantees that are tailored to what DEX users may want, but in conflict with other use cases.
So I'm COO of Celestia Labs. And at Celestia, we are building the first modular blockchain network. So what that means is that Celestia actually does no execution. It's just a very simple data availability layer on which other people can launch their own blockchains, and they can customize the execution environment to suit their needs of whatever kind of application they're running. And you can think of Celestia as kind of like this shared security layer that anyone can plug into and consume the block space of.
And Nick, could you expand on that? I know, we're trying to tease out kind of the spectrum of app chains in this season, and I think of it, on the one side you have full stack app chains, and on the other end of the spectrum you have something like Ethereum L3s that settle to a shared L2, and then down to the L1. But in the middle we have modular app chains, and I think that there are a lot of different flavors of what this could look like. I think Sovereign Labs the other day released some information on the Sovereign SDK. But I know there's lots of other projects that are building, on Celestia or leveraging Celestia in some way. So yeah, would you mind just kind of unpacking the different flavors of app chains that can be built using Celestia?
Absolutely. So I would say on Celestia, you can build an app chain as a rollup. So essentially, as opposed to the Cosmos model where you have to bootstrap a new consensus network, you have to get a bunch of validators and issue a proof of stake token to secure the network. On Celestia, you get a consensus network from day one for free, and so it really lowers the overhead of launching a new app chain. But you still have the full ability to customize your execution environment, your fees, and all of that kind of stuff. And then actually, on the other side of the spectrum that you mentioned, the L3s on Ethereum actually can build the same type of architecture on Celestia as well. So there are actually teams building sort of like layer 2 settlement layers, and on which people will launch L3s that settle into those rollups on top of Celestia. So we can actually support that full spectrum. What you cannot get, and I think Dave can expand on this, is that Celestia is doing the consensus for you, so you're not actually controlling at that layer of the stack. However, we can talk about this. I think that the most important things you can control as far as the app chain stack is concerned with a modular app chain model.
That's super helpful, and I think that leads into my next question to Dave. Is why did you choose the security approach that you did, or maybe having better said, why did you choose the full stack approach, and what does that kind of unlock for you at the application layer?
Yeah, and maybe to hit on this breakdown a little bit more first of so you can imagine the traditional first set of rollups where basically outsource data availability and finality to ETH L1, and then but otherwise execution is all this other thing, and you have guaranteed ETH L1 inclusion or a censorship resistance, but otherwise ordering properties are basically on this L2. So part of the claim, or a strong part of Osmosis, was that no, we actually want more. There's much more important things we need. So a DEX should have fast finality. The ETH finality is already too slow. We want consensus changes, or we want to be able to require stuff for consensus to get both stronger MEV resistance and censorship resistance guarantees than we think we could get in ETH, similar for user level privacy. So these force us to be to not just imagine ourselves as or to not rely on ETH for finality or for data availability. You can, in principle, still post to ETH if someone wanted these, but that would not be the canonical root of trust. It has to be its own chain to get these guarantees. Or as our claims, it had to be its own chain to do so. I guess I can expand on why. So, for censorship, we wanted, for MEV resistance, censorship resistance, we want to add this thing called threshold encryption, where the idea is that we have this validator set we trust. We want all data to be, basically, all transactions should be encrypted in such that no individual can read them prior to them being finalized. So, and then we want to basically delegate to this committee that upon it being finalized, decrypt, post the execution, or post the decrypted contents, and execute. So you have this problem though of who do you make this this committee, and how do they have this tight guarantee around finalization? But this is actually kind of elegantly done if you're in a proof of stake Tendermint environment of in proof of stake saying this committee is your finality engine. They're running consensus to get finality on stuff. So you get fast finality, which is really important. And then so the set ensures fast finality, and we can ensure that whenever something is final, it must be decryptable. So by having the same set be in charge of basically both finalization and decryption, these can be you can get very tight guarantees for users on this. So this is why it's really important that it's running its own consensus. That is quite finalized.
It makes a lot of sense, and I think last week we touched on this with Sam, and I think one of the biggest and most compelling reasons to go with the full stack approach is really from a DEX perspective, it's around performance and finality, but it's also around enabling some of these really interesting privacy capabilities that we'll see from Osmosis Anoma, Penumbra, and a few other Cosmos chains. So I guess I would turn it over to Nick. We've talked a lot about what the role of these validators, app specific validators, can do. How do you compare I guess the role of sequencers for the rollups on Celestia to the role of validators on a full stack app chain? Can they have exert the same level of control or opinionation over things like transaction ordering, custom fees, or even MEV capture, right? I'd be curious to hear how you would react to that.
And I'm just going to raise my hand, Nick. Before you answer that, could you just define for the audience as well what a sequencer is? Like, what is the sort of makeup, and then go into answering Miles' question?
Sure. So in a modular blockchain world, even though consensus is handled at the L1 layer, like let's say Celestia or Ethereum, providing the data availability, you also have to have a node or a set of nodes that are running the roll-up execution and that are ordering the roll-up transactions and then posting them in a batch to Celestia. So the sequencer is sort of like the node that is running the roll-up network, if you will. So the sequencers in a modular context do have control over ordering. So they do have an ability to sort of extract MEV, and they also kind of have an ability, if you want, to attest to the validity of the block that they post. And that can actually give you a measure of finality if you need it. And what's really interesting, so like it won't be the same level of security of finality as once it's posted to Ethereum, but it can give you at least a level that is useful. Because like finality to me is not like binary, it's not 0 or 1. It's kind of like the amount. Finality is more defined by like the economic sort of security of that is guaranteeing that transaction won't be reverted. So you can actually get that at the sequencer layer as well. So I don't think necessarily you have to run your own L1 if you want fast finality, because there's mechanisms that you can get that even as an L2. The interesting thing is that the whole landscape of sequencers is kind of still evolving. I think it's actually probably the most important layer in the modular stack after the data availability layer. And there's been a lot of discussions recently about how to build a shared sequencer network. And this shared sequencer network can do a lot of things. It can ensure more censorship resistance, and it can ensure liveness of many rollups. And many rollups can actually sort of use the same set of sequencers. And you can also bake in things like threshold encryption or like fast finality and attestation at that layer, or even we've discussed internally about maybe in the future, does it make sense for Celestia itself to have threshold encryption? The thing is that doesn't quite make sense, because unless the users themselves, the users are actually using the rollup, they would need to like encrypt their transactions and send them directly to Celestia. So it probably makes more sense for it to exist at the shared sequencer layer. But anyway, long story short is sequencers are a really, really big part of this whole stack. And I see them as like still very much kind of in R&D, but it's probably the most exciting space within the modular stack.
Yeah, no, I could not agree more. And I think maybe one other question as really, on that same path of the sequencers, comparing sequencers to validators. I think, Dave, like superfluid staking is a capability of Osmosis that maybe is a good example to use here, where the consensus layer can understand the application layer, right? And so it can, assets that are locked on the application layer in LP pools can be staked based off of different parameters approved by governance. Do you think, a question, I'll throw it to either of you, how important is it for your sequencer set or your validator set to be really application specific and optimized to understand the semantics of the application versus, taking a shared sequencer or a shared validator set approach, like interchain security provided by the hub, or what we're talking about here with shared sequencers with rollups or roll apps?
So I think something that's actually really exciting that's been happening over the last 2-3 years is actually really trying to answer this, or like understand this question. And I think to understand it, you have to kind of dive into what are we getting security for, which is also I think relates to like how you make a modular architecture. So for so finality is like there are, I guess, two big ones is like finality and state execution validity. So so if we're imagining we're living in a world of async different environments want to talk to each other, but then they just want to trust some committee or trust and then trust some committee that state or computation was done correctly. This is like kind of one paradigm. This is somewhat like, this is how IBC works today. This is how kind of optimistic rollups, this is the regime they're in. The second one is you have things that are verifiable, like there are ZK'd, so you actually don't need to trust the computation was done correctly, up to like, bugs, but it's not the biggest. So what you need out of state execution validity differs between these. So in this IBC context, like, having high confidence that people are just going to trust the state root you give them. So there, you need to like think a lot about how we're going to ensure the state root is valid, and so there, and if the state root was invalid, then arbitrary bad things happen. All value on this chain can be stolen, and but this does in some sense go down, or this risk goes away with enough cryptography work. Other parts of this risk is finality of like, what's the chance if we want to commit to one thing, or there's two parts. One is the happy path of like, or not happy path, like kind of the regular one of where just this blockchain's chugging along. And then at what point can you trust that block B is not going to be changed for another block? So nice entanglement is like we claim that it's like one block in the happy path. That like when you see block B plus 1, you know that B is finalized. In Ethereum, it's 2 epochs. Different proof sequence, different things. Proof of work has some that doesn't exist probabilistic, but there's a second path to this, which is like actually I think often missed when people talk about modular architectures, which is like fork choice rule, where suppose there is a fork, how do you know which fork to choose? And something that's like a problem with outsourced data availability on its own is that data availability, but not like your finality, is that if a DA layer censors, then like the DA layer can pick your fork choice rule, not just your happy path finalization committee.
Interesting.
Sorry, actually, I think I strayed from their initial question though.
No, not at all. Not at all. I think that's. I mean, it's getting a little bit away from the application side, but it's still it's extremely important. I think maybe another question, just to unpack some of these details, is it's pretty clear how a full stack L1 is secured, right? Or a full stack Appchain is secured. It's with the native staking token of the application. And Nick, for some of the rollups on Celestia, what are the different ways that these sequencer sets are securing themselves? Do these sequencer sets need to post collateral from something like EigenLayer? Will they have their own natives, I guess, gas tokens? Or are there a lot of different flavors that you can explore here?
Good question. Well, I think it's tricky because security can mean different things, right? So it's kind of like what Dave said. There's security in the sense of like finality, which is like consensus. A block is not going to be reverted. There's also security in the sense of the validity of the execution. And so in a modular stack, the finality is ensured by the consensus of the data availability layer, like Celestia or Ethereum. But then the validity is ensured by data availability sampling and the proof system of the rollup. So either optimistic proofs, like fraud proofs, or ZK proofs. And actually the shared sequencers don't really have a role as far as like security is concerned in either of those contexts. All that they do is they provide censorship resistance and liveness and ordering basically for the rollup. So they're not actually they don't necessarily have to play a role in security, although in some models the sequencer also will be maybe the proof generator, or maybe the person sort of like watching either generating the ZK proof or generating the fraud proof. But there's also models in which the sequencers are totally dumb and they actually don't know anything about the execution of the rollup. And they're just more, they take in transactions, they order them, and they post them on Celestia. So it really depends on the model of which that you're choosing. And so that's why it's really interesting that it's still kind of to be determined, like how much should these sequencers, these shared sequencers, know about the execution of the rollups that they're ordering. I think in practice, they might end up knowing quite a bit just because of MEV, or maybe there's some sort of like other model where the block builders kind of bid to have their blocks like posted by the shared sequencer. So there's still like a lot of different things. But back to your question of like, do they have a token? Most shared sequencer networks, I would imagine, will have a token because they need to have some sort of like leader selection of who has the right to post the next block for each of the rollups that they're ordering. And so there will be some kind of mechanism, and I think there will be a token to facilitate that, and probably also some sort of like fee mechanisms for people to basically pay for the service that the shared sequencer network is performing.
To one of your earlier points of like, so I think it's up to the app for what are extra security properties it wants. Like, so for instance, in ordering, in censorship persistence, like, this is it's a question of like, is this a security guarantee or not? And then what do you need for it to happen? Like, do you need, if I have a goal of high censorship persistence, does that mean that I should be able to let, how many alternate DA channels do I need? Do I need like my blocks to be forced to get input data from? I guess in ordering, you guess you have a split of like, you can have sequencers be forced to provide proofs that like, here's the list of things I thought about, or I guess there's, or you can attempt to have like different types of ordering guarantees, like randomized ordering, or attempt to get provable FIFO ordering at the mempool layer. And I think this is underexplored, though I do wonder like how much depends on like DA layer choice or number of DA layers.
Yeah, and I think one thing that maybe just to touch on something Nick said was around, we'll see a spectrum of sequencers, and some of them will be, will really actually understand what's happening at the execution environment, and some of them will just be more of a sequencer set as a service and shared between a lot of rollups. I guess, how do you think about the trade-offs of that, right, from the perspective of an app builder? Because when I hear that, I think about, Osmosis and just how opinionated Osmosis can be about things like transaction ordering, right? MEV protection, even things like social slashing, right? I'm wondering, is the trade-off really around the interoperability of these L3s when they share a sequencer set versus the amount of opinionation that they can have at the sequencer level? Or maybe, Nick, it's better said, who really controls the parameters of the sequencer set for these rollups to let them do things that are opinionated or maybe not?
That's a really good question. I think that obviously, like the sequencer, like if there is a shared sequencer network, it is providing a service to the rollups, right? So the rollups are its customer. So there can either be like an adversarial relationship where they try to extract MEV or, do things that maybe are not actually incentive aligned with the customer, or they might be trying to actually align incentives. So I think of, models like Skip, which is, building MEV Tendermint and kind of rolling it out across the Cosmos ecosystem as a way for Tendermint validators to extract MEV, but not necessarily for themselves, but to redirect it to the stakers and like the token holders or however the community wants. And I foresee shared sequencer networks emerging that have similar kinds of mechanisms where you as the rollup kind of can configure these parameters. And then if it turns out, and by the way, I imagine it's going to be a competitive landscape, right? There's not just going to be one sequencer network, but probably multiple. And if one, it mistreats you or ends up not really upholding its side of the bargain or just doesn't offer this kind of functionality, you can always go elsewhere. And then there's always the other option, which is you don't have to use this at all, and you can run your own set of sequencers or single sequencer. Like there's so many options, and at the end of the day, I think the rollups themselves will get to choose what is best for them. Like there is no lock-in, there's no like capture in this model. And that's also what I love about modular blockchains. There's just so much freedom to move to whatever works best for you. You're not sort of stuck, in any one like model.
So, well, what I see happening is I think there's like not really anything special to sequencer layer in this DA land, not DA, or outsourced DA, not outsourced DA. I think like what I see happening is what the apps or chains want, and I think what they should be doing is like, here's properties we want to enforce. How do I make it provable that these were enforced? Either how do I make it provable that these were enforced, or make it such that like users cannot will not suffer from this. So you have a space of options. Like suppose I say sandwiching is bad. I could imagine that once I'm in my option space, okay, well, you can batch execute stuff. You can say that no one can know the data content, so they can't be front ran or sandwiched. You could also say that like, okay, here's this algorithm that says that is a sandwich detector. If your block proposal satisfies this algorithm, it's an invalid proposal. Go to the next proposal. So we have this space of things. Like I think the third one is what's I think most underexplored. Like maybe sandwiches. I contend this is like doable, but sure there's some time complexity to it. But there's many things in this like how would you ideally opine about block space to be that we don't have to go towards like fully just trust sequencer. No, sequencers can do proofs. Like they can snark that here's a list or that this block proposal like satisfies validity criteria, or here's a list of things I've if you're fine with SGXs, you can like have some guarantees around what things you receive in the mempool. Well, and then some property is upheld.
Hey guys, I've got one maybe question on the slightly less technical side, but from the perspective of a potential app builder out there, like a founder, something that I've sort of found it helpful, or an underappreciated aspect of success, especially in the early days, is the ability to focus. So Dave, I've kind of heard you say like some of the advantages, right, of being able to control, have your validators understand the semantics of your app, but also like in doing so, in having like a full stack approach, there's so many different layers that you as a founder, your brain is going to need to worry about and contend with, right? Whereas I see sort of the advantage of a modular approach like Celestia. There's a lot of stuff that, maybe I don't have the same degree of control, but I also don't have to worry about that. So I'd love maybe the two of you, if you almost want to make like a pitch, right? If you were talking to, Dave, another founder, or Nick, a potential founder that was going to build on Celestia, like how would you sort of tease out the pros and cons of each approach, purely from kind of an app chain builder psychology?
I'll go first. I think you bring up a really, really good point. And that's why, Celestia's mission is to make it as easy to build your own blockchain as it is to build your own smart contract. Because if you think about what made Ethereum so successful and why, we have applications like DeFi and NFTs and all these things, is that Ethereum made it extremely easy to build your own decentralized application so everyone could experiment, right? They didn't have to before with Bitcoin, and then sort of the Bitcoin era, you had to actually build your own blockchain from scratch every time you wanted to try a new app, essentially. So Ethereum kind of unlocked all this innovation, and Celestia aims to do the same thing, but actually a layer lower, where you're not just building a smart contract, but your own blockchain that is more scalable, and you can actually change the execution and all that. So
how is Celestia doing that? Where like if I was fine with something just being single, so if I'm saying I'm building your own blockchain, what do you mean? Like if you how does a blockchain I guess differ than like someone? What's the decentralization need of how are you defining it? It's like a single sequencer. Are we calling a single sequencer roll up a blockchain?
So Celestia's broader mission is to do that. I'm not saying that Celestia protocol itself achieves that on its own. It's the full modular stack, essentially. So Celestia provides the data availability and consensus, but there's other missing layers. For example, I think a shared sequencer network that you can plug into and just basically say, hey, I need you to do the sequencing for my rollup. And also all these execution environments that actually are fraud provable or validity provable. So there's a full stack of things. But once we have this full stack built out, I think that you'll be able to deploy a rollup, which is just a blockchain. It's like a virtual blockchain, as easily as a smart contract. That is, you will basically define the execution environment that you want to run, and press. Hopefully, it's as easy as like clicking a button, essentially, and you get all the properties of validity, finality, censorship resistance, and all of that kind of out of the box. That's the end vision of the modular blockchain worldview.
One thing that I just purely a matter of curiosity, Dave, I'd almost love to hear sort of the early days of what it was like to recruit a network of validators. Like, everyone kind of understands, right, that that's a difficult thing to do, and that's sort of one of the main obstacles, right, to building your own full stack app chain. Like, how did you in the early days kind of get your name out there, and like, how did you get people to take that first shot and believe in Osmosis?
Sure. Though I do want to point out that I think there's a little bit of a Mod and Bailey in this comparison of like this validator accrual for finality is if you're trying to make an apples to apples comparison of like build your own blockchain via stack A or stack B being like outsourced DA to Celestia, then the validator accrual problem still exists. If you want to not outsource, if you don't want to outsource finality, you want to outsource finality, then you're a single sequencer rollup, and then like the comparison point should really be like Ethereum, or like what is this rollup versus like what is the consensus and finality demands you want. But I guess now to then like, okay, suppose we're trying to make the comparison with like non-outsourced finality of like I want to control finality myself, then to get validators, I think what's nice about having a common stack, like we have a common stack in Cosmos of like everyone people who build their chain via Tendermint and the Cosmos SDK, they have very common tooling. So there's very little training overhead to get people. It's mostly like a willingness overhead. So for Osmosis, this actually wasn't a big problem. Like at this time, there's actually like several hundred plus validators who are very eager to like just validate on networks. And I guess at the time, we just asked people who were interested in securing this, and like, there was more than enough people who had who participated in the airdrop to be who were like just willing to sign the Genesis transactions to join. So it's actually like not an issue. This is not the case for I think most app chains that start, because there they have some like vying for attention, but at least so in that sense for most new app chains, I guess they have to like they have to like kind of make a pitch for why should people want to validate this. I think a missing thing, which this initial like shared security stuff, a lot of the shared security, mesh security stuff is like working towards is basically getting it builds towards the end some permissionless way to get this initial set of these are just consensus and DA operators or finality and DA operators. They actually don't want to look too much at your execution layer. It just runs some Docker containers. Then such a product can then it's like your blockchain just does a governance proposal, say like as a set, or is there some subset of you who like is willing to take these tokens and then like run this validator service?
Yeah, I think that's a great segue into what I wanted to ask you about anyways, which is kind of how we see these Cosmos security models evolving. And specifically, I think I would love to, if you could share a little bit more about what mesh security is, how it is different from some of the top-down security provision models, like the hubs ICS or Ethereum rollups. And I would like, if you could kind of dig into how what it means to be like a bottoms up approach here. Is it similar to eigenlayer restaking? Just kind of how you see this evolving.
Yeah, I think it is pretty similar to eigenlayer restaking. Like I think it's like exploring the same question of what do we actually care about when we measure economic security? And so in proof of stake chains, to date, most of it is like we've staked some high percentage of our token, so it's hard to buy up more of the token. And so, therefore it's like, because it's hard to buy the token, there's no one who's going to accrue 2/3 and perform an attack. But there's a number of issues with this. One is like there's a circular value problem of like we're trying to measure economic value, but some of this economic value is like coming from it's securing this chain. And so one thing is let me back up. If you commit a fraudulent act, then the claim for why you don't do this is twofold. One is this: you're going to drive the staking token to be worthless, so that's a huge loss. And two, you're directly slashed, so there's like funds burned. So you get downside from these two things. But this is a very circular argument. So something that's like basically these mesh securities and eigenlayer restaking like question is like, okay, well, why can't I have other tokens do this? Like let's have Atom or ETH as collateral. Well, these have like other economic factors, so they're like they have higher worth. Like a lot of tokens, like basically like tokens in the early days, like where does value come from? This is not the same question you have for like an Atom, ETH, Osmo, or like Bitcoin. Like these assets have value because of like some other number of reasons of like actual integrations. People care for whatever reason people care about stuff. But it's not because of your chain directly. So then, if there's a fraudulent act committed, like these tokens can be burned, so they are like contributing to economic security. So the idea of the mesh security is saying that, there's chain A, or I don't know, maybe let's call it new chain. New chain A, and it has its own token foo for being secure, saying I'm also willing to reason about the worth of like Bitcoin and Ethereum or Osmo. Like then they'll let people stake these assets, like, or it'll let people. So I guess let people stake these assets for like Bitcoin, Ethereum, Osmo. To help secure chain A. But now something's interesting is, well, people might not want to just have their Osmo only getting chain A's like rewards. They can want their Osmo to actually have like multiple usage, so, namely like securing Osmosis and securing chain A. And potentially another one is like if protocols are willing to take in this risk, also be in a lending market, like accrue some like lending interest rate, and then be securing the network with like the claim that this securing the network with unlent out Osmo.
I've got a question for all you guys on this actually, which is, and this is something that I've sort of mentally thought about like listening to, because eigenlayer is an extremely attractive value proposition, right? This idea of sort of restaking and lending out, the security model of ETH to different chains. The question that I always have is, what would cascading liquidation sort of look like in a scenario like that? Because I think interoperability becomes something that's worthwhile to discuss. And even like in a Cosmos sort of lane where you have IBC, that's still light clients. And at least my understanding is the least technical person on this recording is that there are still some limitations when it comes to IBC and just running a light client. So my question to you guys is that a concern at all? Am I being too Debbie Downer about that?
No, it's huge. You do need to consider the contagion risk. So here's maybe another case it's maybe simpler and interesting. I'm chain A, and I have a bunch of coin B securing my chain. And today, let's say like 80% of the worth is in my own coin A, and then like 20% of the worth is in coin B. Suppose coin B 10x's. Well, now who used to be a minority coin B holder on like chain A is a controlling set, and can like screw over my chain. So there is this problem of too much external dependency. Because then people who had a small amount before are already here have controlling majorities to do attacks. So you need to think about like what's the total amount of risk you've outsourced out. Once you add in lending markets, this also becomes concerning. Though what I think is concerning more is like contract risk or lending market insolvency, where the biggest advantage of DeFi is that our lending markets are unlike FTX at all, are like have some algorithmic solvency on chain, except there's actually edge cases or important details when they don't. But in general, like your protocol should, in this mesh security landscape, like have this reasoning of like, what is this risk factor and how many independent sources of value. So like, suppose there's 10 other chains that are highly correlated. I should say that no, the sum of these chains cannot be more than like 33% of my security.
Got it. And that could be Tendermint security or governance power, right?
So it's like unclear why you'd want to outsource. Yeah, so I guess with all mesh security stuff, it's also important to note that like we're separating the roles of consensus stake and governance. Of like, it's a question of you probably don't you may never want to outsource any governance and just consensus like security or tenor finality security.
No, I think that makes sense, and I think another trend it's being talked about, or potentially a future trend for Cosmos chains in evolving these security models, is potentially outsourcing or unbundling parts of what they do today to, say, a DA provider like Celestia, or a combination of Celestia and another interesting project called Babylon. I would point to you, Nick. Have you been in discussions with a lot of Cosmos chains about potentially unbundling part of their stack and outsourcing it to Celestia, or is it more on the Ethereum rollup side?
Yeah, actually, I would say a bit of both. We were actually building this sequencer software that is ABCI compatible, so it means it's compatible with any application or state machine that sort of like conforms to the Cosmos SDK interface. And so what that enables people to do is to run a Cosmos SDK application on top of Celestia. And so there's actually been a lot more interest in that than I expected. And I think it's because the value prop is actually very strong. It's like, oh, well, before I want to actually like expand on this point about like the overhead of launching your own blockchain, right? And I actually saw on Twitter, there was a great analogy by this guy talking about cosmology, which is actually just unrelated to shared security, but it's actually this toolkit that helps you sort of like build the front end and interface for a Cosmos SDK app. And he said that, asking what cosmology does is basically it makes it so that like Jimi Hendrix doesn't have to build his own guitar in order to write his own album, right? And I think I kind of want to borrow that to explain sort of what Celestia does, right? It's like, if I'm an app chain builder, what I should care about is my application. And I shouldn't have to worry about all the other layers of infrastructure and all the other, like the overhead of getting a set of validators, issuing my own proof of stake token. And then it doesn't just stop there. It's also that you have to continuously maintain that network and pay a security budget that compensates all those validators. So what's so nice about Celestia is that you don't have to do any of those things, and you don't have maintenance and an ongoing security budget. You just pay transaction fees. So the overall like cost to run your blockchain is like diminished significantly, and so it also makes your application more profitable, if you will. And I think mesh security is and also ICS are a very good way to sort of bring that cost down. But I think they add, well, in ICS's case, I think it's not quite as cost effective. It's also not permissionless. Like we want it to be permissionless as well for people to deploy their own blockchain, right? And then with mesh security, I think there's just a lot of complexity. And while it is, again, an improvement over like not having mesh security, I also have a lot of concerns about the security of a model like that, both because of the contagion stuff, but actually more from a fundamental perspective, which we can get into on another time. But essentially, it's very hard to slash assets that are not native to your chain if they misbehave. And it's very hard to prove that validators are misbehaving in a smart contract on another chain. There's just like limitations to that, unless you have data availability or some kind of like proof system, so you kind of end up, in my opinion, to make mesh security fully secure, you kind of fall back to like a modular blockchain model. But anyway, yeah, like at the high level, Celestia wants to make it so that if you're Jimi Hendrix, you don't have to worry about, like, the guitar is just in your hands for free, and you can write your own album and just like jam and not have to like, start from the very beginning and like, build the guitar from scratch.
Right. And I think that that's part of the value prop. You can iterate and find a PMF, with the minimum viable amount of cost.
I feel
And
like
then
half the benefit you described though was like single sequencer versus decentralized sequencer. It had nothing to do with data availability. Like no one who writes a Cosmos chain like is actually aware of the data availability because Tendermint is your DA proof. It's a DA proof amongst the validator set. Like the comparison for making it easier to launch a chain is like in the proposal you're making is this like, okay, you can go make single sequencer blockchains or single sequencer, or like, so like, what does that mean? Like single validator things. If you're trying to have decentralized validators, like, then you need, still have this multi-validator coordination in basically the same way. Like, you need finality, etc.
I don't really follow that point.
Okay, so the claim is that it's easier to like make a chain because you don't have to have this like maintenance of like staking rewards or like coordinating amongst many validators for upgrades, right?
Just in the interest of time, there's an important concept that I think both you two are sort of dancing around that Miles and I really sort of want answered. And maybe this is a good time to get into it, but I think both of us have sort of been wondering, and actually Zachy brought this up on the last episode that we aired, which is sort of this concept of like the minimum viable stack, right? Like what is the sort of minimum viable stack needed to, I think eventually over time, the vast majority of sort of successful founders in crypto today are technical founders for obvious reasons. I think over a span of time, right, what we're trying to do here is build a stack so that you can abstract away some of the more technical components and thus increase the surface area for less technical founders to come in, right? So I think Miles and I are both kind of trying to tease out, like, what does that minimum viable stack sort of look like? What are the important sort of layers that need to get built so that we can achieve that end?
So as one thing, it's like I think a huge achievement of the Cosmos stack today is like its big achievement in my MO is it's abstracted out consensus from you entirely. That now all you think about abstracted out consensus and like bridges. So all you have to think about is how do I want my application to exist, but now like bridging and how you do consensus is like solved. But there's more parts to how to build an application that are limited right now, and also more security properties that are limited that you still are forced to think of. Like, I think we're gonna see in the future a lot more abstraction around like MEV components, like things that are just like import a library to have this set of MEV resistance tools rather than just like having to write about it, or even like think about we can have if imagine there's a common stack for MEV or data inclusion. Then you don't have to think about it as much. Like,
I guess I think you make a good point. I mean, the Cosmos SDK is really the only one of these stacks that's kind of reached exit velocity, right? It's the only Appchain stack that's really in action here. I don't know if it's a good point this to either of you, but I think it's important to talk about the network effects around sharing the same SDK or sharing the same stack. And I guess, how would you think about, what's been the most important part of the SDK success, and how that might lead us to think about what the next, competitor to the Cosmos stack could look like in terms of, Appchain specific stacks?
Dave is probably more qualified to speak to the Cosmos SDK thing. But at least, so one of the interesting things is that Celestia is very Cosmos aligned. And in fact, Celestia as a DA layer was built using Tendermint and the Cosmos SDK. And we made a lot of modifications because it's kind of like a very unique thing that hasn't existed before. But one of the benefits that we've seen in the network effects around the Cosmos SDK and Tendermint are things like Dave already mentioned, IBC. We get interoperability with all these other blockchains out of the box, basically for free. We get all these wallets, we get explorers, we get all this infrastructure that is just compatible by default. And that's a huge like weight off of the shoulders of someone building a new blockchain. And because I actually went through this before Celestia. I built this protocol called Harmony, and we had to kind of do a lot of that from scratch. And so I know the pains. So anyway, I think that the Cosmos SDK is definitely the farthest along from that, like build your own blockchain perspective. But I think that the cat is out of the bag, and there's a lot of teams all trying to think about like, whoa, what could like the next iteration of this be, especially within a more modular context. I think a lot of the abstractions that Cosmos SDK makes can actually, and even like the IBC can actually be sort of like translated into a modular sort of paradigm. And there are teams doing that, but there's also things like Sovereign, which you guys mentioned earlier, which are building like a whole new version of it, but like a ZK version of the Cosmos stack. And I think there's going to be a lot of experimentation and innovation, at least from the modular perspective. But Dave probably has a lot more to say.
Yeah, very much agreed. Where I think there's a number of axes you can massively improve on the Cosmos SDK today. Like one big one's like DevUX, like just make everything you want to do today already just like thousands of lines easier. But there's more infrastructure you could want just made for you, like state machine validity, or like, the thing to do is get ZK proofs. I think what's going to happen, or what should happen, is, and it's like something that Substrate got right, is you get all of your state machine code compiled to some VM, and then you have like snark proofs of this VM. So this is a research task in Snarkland going on of like, how do we keep getting 10, 100,000 X's of like speed ups and snarks? But I mean, I don't know. I feel very convinced this is going to happen from like spending time in like how we construct these things. So then we'll eventually be at this point of like, you can snark prove very efficiently some common thing like RISC-V, Ojha is doing it, with perhaps some mild ISA addendums, and so then that's something you can have this prove or get out of the box for you. Other things are privacy. Like there is to date basically no good privacy toolkit for the front end, for like front ends, where you'd want your stack to just like have privacy by default and have this JS libraries that like let people like shielded view their balance and not have to think about this, or like just create the ZKP transaction. In censorship resistance, there's a suite of things like it should just be like it just come by default of like we can inherit censorship resistance from our peers along the network that we talk to, or peers meaning like other chains you connect to, rather than having to think about it yourself. So I imagine like future stacks will like basically make the DevUX of building the apps people want to build today already much easier. Here, come with new like more and more infra or security properties just like guaranteed that you don't have to think about. And I guess maybe there's axes of like iteration that the Cosmos SDK doesn't let you do easily. Like it's hard to change out the consensus algorithm out of Tendermint. Not really because of like there's an interface boundary which is good. It's just like no one's actually maintaining a second thing behind the interface. Or fee markets, right? Like some things Appchains should be doing the most of is like playing around with fees, like fee markets, how we express what goes into a block and how we charge for it. Whereas actually today, like the two biggest experiments in the last 2 years weren't in Cosmos. They were in like EIP 1559 in Ethereum and Solana in like their basically pretty actually extremely interesting method of like just charging gas for repeated contract use in the same block.
No, I think that all makes a lot of sense, and I think when I think about the stack, I think of shared consensus layer, either just using the same consensus model like Tendermint, or actually having the shared security set. I think about shared interoperability standards, and then I think about potentially shared VMs or the application environment, right? And do you think the next, I guess, minimum viable stack for Appchains will it share the same interoperability standards like IBC with the existing Appchain stacks, or do you think we could see a lot more of these interoperability standards come up over the next few years?
So I think as a transport layer, I think IBC is like basically what you want, except it needs one more feature. Basically, this additional feature you need, which you still can do right now, but it's like not standardized, is amend a ZKP for what you verify. So like today, IBC is just light client guarantees, but if chain A can do a zero knowledge proof like Mina does, or hey look, I computed this block correctly, then you can verify this over IBC to get this guarantee. So something I think is like extremely exciting is like all these ZK rollups for the EVM, ZK EVM projects are basically doing this, where all new EVMs, like ideally, or all EVM bridges in a year from now should really use like these things. That way we get this guarantee. We should amend it into IBC. Then I do think there's still room for like I think like cross-chain synchrony guarantees have barely even started being explored. Like for token transfers, we do the simplest thing of like this atomic burn, but how we imagine like decentralized applications talking from one chain to another is like barely even started.
I've got one sort of question here. I want to actually close talking about MEV because that's what our next episode is going to focus on. And Dave, I've heard a little birdie told me that you have some pretty strong perspectives on MEV, but I've got a question for Nick before we get there, which is, Nick, you just mentioned Celestia being sort of aligned with Cosmos. And again, just on the theme of trying to like really put myself in the shoes of like if I was going to launch an app chain tomorrow, I'd love to get your thoughts on sort of the BD and distribution impact of deciding to align with different ecosystems. So I was listening to, again, not to keep referencing, I was listening to an interview Sriram did on, I think, 0x Research, one of our other podcasts the other day. And he sort of mentioned one of the advantages of eigenlayers, you're sort of plugging into the ETH ecosystem. And there's a lot of like distribution that sort of goes along with that. And, there are a couple of different approaches, which is to sort of like align yourself with a specific ecosystem, like the Cosmos ecosystem. But then you're also seeing these sort of flexible, sort of modular execution layers that could kind of plug and play with like Celestia, kind of any different, kind of settle back to any L1. And I'd be curious, like outside of, we've focused a lot on sort of the technical components of that, but what's the sort of distribution and, business development impacts of like aligning with Cosmos or Ethereum or positioning yourselves as kind of a neutral, execution layer that could plug into either one?
That's a great question, Michael. I just want to mention on the previous point really quick, two things I think are really interesting in terms of improving the Cosmos stack or like the build your own blockchain stack. One is there's kind of a, I think it was an open question of, I think it could be a better interface than ABCI, and people are actually kind of working on and envisioning what is a better kind of like abstraction between sort of like the sequencer layer / consensus layer and the app layer. And so I just want to pose that out there for hopefully people start working on that, because I think there could be something that's more generalized. And the second thing is that one thing that IBC does not currently have is actually like an ability to verify sort of like the state validity. You only verify that like the block is finalized and that it's attested that the state is valid. And something you can get in the modular stack is actually proof that the state itself is valid. And you get that when you share a common data availability layer. And there are teams like Polymer that are working on kind of extending IBC to make it more modular friendly in terms of like, compatible with proof systems. So anyway, those are just 2 points. But on your point about alignment, I think that's really an interesting thing to open up. And I want to start by saying that Celestia is credibly neutral. And so we don't favor any particular ecosystem or type of builder. We're just like a very simple data availability layer that anyone can use. That's why, for example, we haven't enshrined any kind of execution in the chain or settlement layer. We haven't built any rollups on our own because we want to be fully credibly neutral. That said, obviously we built the blockchain using the Cosmos stack, so we'll have IBC and probably be connected to chains like Osmosis and whatnot at the L1 layer. And we've also built things like Rollkit, which are compatible with the Cosmos stack because we felt that that's really where the app chain ecosystem exists and is most mature. And so, we anticipate a lot of people to be building Cosmos app chains using things like Rollkit in the future. But in practice, we've also just seen a lot of adoption of new people coming to us saying, hey, we want to build our own rollup stack and we want to use Celestia because it's currently kind of the only option for scalable, trust minimized data availability block space. So we have teams like Eclipse, which is building a Solana virtual machine sort of rollup stack. We have teams like one that is not announced yet, but building sort of EVM style stacks, and like just a whole sort of like plethora of innovation of people saying, they're not necessarily part of any ecosystem. They're not really part of Ethereum or part of Cosmos. They're kind of like starting from the beginning and just saying, my customer is a developer who wants to deploy their own rollup, and like what is it that they're going to need. and I'm going to provide that to them. And I think that in the future, that's really where the space is going to go. And that's why we say modularism, not maximalism. Like, we don't believe that any stack is necessarily superior, any community is superior. It's really all inclusive, if you will. And we're more about bringing in, rather than fighting over the existing pie, it's about, like you said, bringing in the next, million or, tens of millions of developers into blockchain and crypto. And, that's really where we should be focusing our energy and attention.
Yeah, we could not agree more. And that's a big theme of this season. It's really, let the product determine what the stack is rather than the other way around. And we're really focusing on that because that's where we think people will be caring about in 10 years, right? If we have billions of people using this, these ecosystems. So yeah, maybe just to end here as a segue into our next episode, Dave, you and I have spoken about MEV quite a lot, and we'll have the Skip team on next week, but would just love to hear, kind of like your thoughts on how opinionated, app spaces or app chains or app rollups should be, about MEV, and what are sort of the things that they can do, that make them unique over, say, a smart contract application that shares an execution environment with thousands of other apps.
Yeah, so I think applications should be really should be extremely opinionated, and some of the pains of working on working on very monolithic stacks is you can't express these; that you have to suffer. So I would like to say no to sandwiching in a number of ways, from something as simple as it's impossible to submit a block that just has sandwiches to make my application have batching guarantees. Or some other forms of MEV are lending market liquidations of great. It is good that people can get a lending market liquidation to happen as soon as possible, in the first transaction in a block. It's bad that the current system that can get dozens of conflicting transactions that waste block space because block space could be at some low price. This liquidation can earn you a lot, so it's you're fine taking the risk of failure. And the protocol itself, the lending market isn't capturing any of this valid surplus value. So you should be able to have your blockchain basically blockchain should be able to capture a lot of this MEV opportunity, either automatically itself or express this to a market, but then get a lot of the proceeds of that, not just unlike today where it's just transaction fees. So to do a lot of this, you have to have extremely fine-grained, or more fine-grained control, saying what blocks are valid, what aren't, giving apps more execution-style parameters, and getting your sequencer or validators to be able to auction off more things in very decentralized ways, where you don't want just Flashbot-style things, something entirely external handles this, and you acquire lots of benevolency in different steps to have safety or decentralization. You should want the chain to do it itself, so that way you can never have single vendor lock-in for any key assumption. So I think the space stuff is huge, and we need Appchains to be iterating way more on figuring out ways to express the semantic.
Oh, couldn't agree more, and we'll dive into that next week. So appreciate you giving us a teaser there.
Yeah, guys, you both have been super generous with your time, and I know we've got to wind down here in a minute. I guess I'll just call on each of you if you want to just do almost closing statement or argument, or just sort of bookend sort of the point that you've been trying to make basically in this episode. So I don't know if either of you have any sort of closing thoughts that you want to leave the audience with, but I'll sort of open the floor to both of you to give you that opportunity now.
Sure, I can go first. I would say that again, modularism, not maximalism. Let the best product win, and Celestia happens to think that the modular stack is really where the puck is going and what will end up being better. But ultimately, it's where developers choose to build, where teams choose to build. And I will say that the modular stack is very nascent and young. Celestia actually hasn't launched yet. We will be launching later this year, and there's still a lot of things to be built. And so I'm also want to open like invite people. If you're really inspired by this vision, there's like no shortage of amazing ideas and things that you could, like products that you can build or protocols you can build in the modular stack. Like I really think we're kind of redesigning what blockchains can be from the ground up. And so there's just a huge amount of opportunity. So if you're interested in that, you want to build your own rollup, we'd really love to get in touch with you and just chat with you. So we have obviously Celestia on Twitter, we have a Discord, we have a forum, and really just like jump into the community. And thank you guys for hosting.
Yeah, for me, thanks so much for hosting. I think I'd ended on, I'd echo a lot of this of like Nick's closing remark of like so much to explore and like re-question of what are blockchains and what can they do. I think that we've in general been far too pigeonholed as like a blockchain community and like how we think about this, and far too accepting of status quos from monolithic chains. And there's so much more we can do, and please spend time thinking about it, and like don't be question all layers of the chain, not just don't assume Ethereum semantics or Solana semantics, or even today Cosmos ones. These should all change drastically if we're like to get anywhere.
Yeah. Super positive note to end on here. Guys, this has been a fascinating discussion. You've given me and Miles a lot to think about and digest, and I'm sure the audience as well. Thank you both so much for your time. I'll have to do it again soon.
Cheers.
Thanks for having us.
All right, partner. Great episode. What do we think?
Yeah, that was a lot of fun. We certainly got into the weeds on that one, probably even more so than the other two episodes. But I thought they brought very unique perspectives. It's probably the first episode where we've had some genuine debate between our guests, which is great to hear. And yeah, it had a lot of great takeaways that we can dig into. Yeah,
I agree. The point of this episode, just to reiterate again for the audience, was to sort of look at that spectrum, right? And we didn't have the Ethereum sort of rollout perspective here, but we did have the full stack app chain and the modular app chain approach. So what did you sort of think of the pros and cons? I think Dave and Nick did a good job of sort of evangelizing each one of their sort of approaches to the architecture. So I'd be curious, like, how did you walk away, thinking about what they said?
We have two different examples here. We have the probably the best example of a full stack app chain that's in production right now in Osmosis. And they were very early movers, which we can talk about in Cosmos, and a highly technical team that was capable of building this. But from day one, they wanted to leverage the full stack to its full capabilities for the sake of the application, right? Whereas Nick is coming at the angle of, okay, well, let's let the application developers focus on their core competency, which is really application development, right? Let's make the process of standing up an app chain as close as possible to being as easy as deploying a smart contract application on Ethereum, so that you do get a lot of those benefits of owning your own block space from day one, but you're not, you don't have the overhead cost of paying for security. You don't have to, recruit chain developers, right? And you can basically get to a minimum viable product as quickly as possible and iterate, find PMF, and then decide, okay, do I want to integrate more parts of the stack? Do I need higher customization, which might come in the form of, moving away from like a shared sequencer set to moving towards something like your own sequencer set, or maybe even going to a full stack app chain with your own validator set. So two different approaches. And yeah, it is important, from the perspective of builder, of where you're coming from.
Yeah, I think, we went into this episode trying to frame this argument from the view of thinking about a prospective founder or app chain builder. And as someone who's a little bit less on the technical side myself, one thing that I found myself wondering when I was trying to put myself in the shoes of someone who was going to, pursue one of these different approaches is, the amount that you need to grapple with to do a full stack approach is mind-boggling. And it is completely to Dave and Sunny's credit that both of those guys are, it probably came across on both the episodes that we've recorded with them so far, wildly smart and wildly technical, that I think that's a lot of the reason they've had success is because, of their ability to grok all these different layers of the stack. For me, I think it was compelling. I think there are still a couple of challenges with Celestia. It's a little bit early in its maturity, and I think the full value prop hasn't been realized yet. But that was a very compelling sort of vision for me, right? Where I think as a founder, I would have to weigh very carefully. I can see the advantage of being able to master all of those layers and have complete control over my application. But also sometimes it's really nice to not have to worry about stuff and be good enough, at a certain layer that you can just say, hey, I'm going to take my mental bandwidth and like really focus in hard on this one layer or problem. And even though the rest of this part isn't quite as good as I'd like, I'm okay with 80%. So I think that's an important thing to consider.
I totally agree. And I think it's probably fair to say and worth noting that the Osmosis, I guess, life cycle is probably not reflective of what an app chain builder would experience today. Right? They were really the first DeFi app chain in Cosmos. They had the support of the entire Cosmos ecosystem from day one, which really takes away kind of like the BD pains, right? And they also had a highly technical team that had, the team is capable of building both the chain and the application. I mean, they're some of the, they are some of the lead contributors to the Cosmos SDK itself. So yeah, I think it's fair to say that an app, to build an app chain today, a full stack app chain today, there is, a BD component of getting, validators to almost underwrite your chain and potentially invest to secure their own stake. And then there's really, okay, how technical is your team? And, to be fair, there are a lot of things that you have right out of the box with the Cosmos SDK. That's a big part of its success, from, a consensus engine to all these modules at the application layer that you can reuse, and, interoperability standards that you can leverage. So, there are teams like I think Stride is a great example of one, which is a liquid staking project in Cosmos. And they were able to stand up a full stack app chain with a team of 5 or 6 in 6 months. And so you can do this, but there is definitely, a BD threshold that you need to accomplish, and also just, finding the right folks on the team which frankly, it's just not realistic for thousands of applications all to be able to do this, which is kind of the world that we see. So I think, there's absolutely a place for a more lightweight approach, and Celestia's modular stack is really promising in that regard.
Completely agree with that. So I think probably it's fair to say that Dave and Sonny's experiences wouldn't necessarily be representative of if you tried to do that today. But I did think his point about how much more difficult is it from a BD perspective, like what does the lift look like of bootstrapping a validator network versus your own sort of single sequencer, I think that was a very fair kind of counterpoint. And I didn't leave necessarily convinced that, again, putting on my founder hat, that it would be a lot easier to kind of stand up my own single sequencer either. I think eventually, right, the vision of Celestia is that there will be different layers of infrastructure and there'll be a decentralized sort of network of sequencers that you can plug into, but that isn't built yet.
Right. I think there's the elephant in the room is that, no roll-up network has really built a decentralized sequencer network, right? These are all single sequencer networks right now that, you might be able to, submit fraud proofs to detect invalid blocks. But I think there is definitely a trade-off in putting your trust in like a single sequencer that you're using for your app specific roll-up, or are you plugging into an existing network of that you're sharing this sequencer network with other roll apps? That, okay, great. Now we have a decentralized sequencer set, but that decentralized sequencer set is serving a lot of different applications. So, just how much can they actually understand in terms of the semantics of the app and to do some of the things that, Osmosis has its validators do, like, control transaction ordering, capture MEV, censor certain sorts of like sandwich attacks and things like that, right? And so, yeah, I think we are still so early on the sequencer side and trying to understand or answer the question of, what can a validator set do that a sequencer set can't do for you at the application level. But I don't think we've seen any app specific rollups bootstrap their own decentralized sequencer set, which would be just drawing an analogy, that would probably be the closest thing to what you could get with your own validator set.
And I actually think, hopefully we'll be hearing from Antonio, the founder of DYDX, and I'm pretty sure that exact constraint played a big, part in his decision to move into the Cosmos ecosystem. I want to talk for a little bit about mesh security. So mesh security was a concept that I actually realized we probably should have done a little bit of a better introduction to it in that episode. So Miles, can you just kind of give us the overview of what mesh security is?
Yeah. So, in the context of this episode, we were talking about, how we see, the Cosmos stack and specifically security models evolving. And I think one of the biggest criticisms of this full stack approach is that, your chain is secured by, the value of your application's token. And so it's almost a bit of a circular dynamic where, if the application's token goes down, all of a sudden your chain is much more vulnerable to attack. And so, are there ways that you can find, can you create additive security by potentially consuming, adding another token to secure your chain, or multiple tokens to secure your chain? And so mesh security is this idea that you can take, a portion, you can basically give a portion of your tendermint power, so basically of your security, and let another chain basically secure that side. And so you can have it's a bottoms up model where the chains are deciding strategically who to align with and who they would like to let secure their chain, and potentially have a bilateral relationship there where you are sending you're hypothecating some of your stake to their chain, and vice versa. And it gets into a lot. We talked a little bit about cascading risk, what this sort of could look like, but I think it's interesting because you could see a future where a lot of these app chains are secured by multiple tokens, and it makes the overall security of the chain more stable, especially if those tokens are uncorrelated, and it also allows I would say chains with very close economic relationships to instantiate a security relationship that reflects that that level of interdependency between each other. Basically, letting if maybe a good one is Osmosis and Axelar, where I would think 4 out of the top 10 assets in terms of TVL on Osmosis are bridged from Axelar. And I think 70% of Axelar's TVL is sitting on Osmosis. So those are two chains that really want to basically be able to check on each other to make sure everything is, all the data that's passing between them is valid. And so that's another angle of this. It's really, hardening these economic relationships, and increasing your security at the same time. So yeah, it's something we're very excited about, and is really taking a more bottoms up approach to shared security versus a top down approach, just something like the Cosmos hub providing their validator set to another chain, or Ethereum providing security to one of the rollups.
It's a fascinating, and there's obviously a lot of merit to it as well. One question that I have for you, on that is I've sort of heard Sunny describe mesh security as kind of the NATO approach as opposed to the Empire approach to security. And not to go too high level with this analogy, but I guess when he said that, I found myself asking, would I rather have the protection of America or NATO? And I don't have to think about that, too much, right? So I think although you remove a certain risk of sort of the evil empire, right? Or let's put this back in the rent extraction power, right, of Ethereum, say, which is more of an empire sort of approach, right? That's something that you want to worry about. But there's also something very simple about it as well. And one sort of concern I might voice about mesh security is it adds a little bit of complexity to it, right? Which is sort of, that would be I don't know what you'd respond to that, but I think it's
No,
just
I think that's a great analogy. If you think about yourself, drawing security from NATO, that involves a large number of these bilateral agreements that took a lot of time to negotiate and maintain. And I think that's probably going to be one of the biggest challenges of mesh, is that all of this has to, it falls on the community to kind of drive the ship here, and actually strike all these agreements and monitor them and continually reassess their security models. And we've touched on this a little bit, but that is one of the biggest challenges of the Cosmos full stack approach, is that you're putting so much on the shoulders of your community's governance, and you're really it's not just the chain developer, it's also all the community, right, that is the ones at the end of the day voting on these things. And so I agree. There are definitely much simpler approaches. But if you think about, a world where there are, more than just say DYDX and Osmosis, but, tens or hundreds of very valuable full stack app chains that have all kind of gotten to that point in their evolution, they're going to need to think about ways to add security and to complement their own, native staking token. And so, this is probably the most interesting approach yet, but there's a lot being explored here.
If I was critiquing us a little bit on this episode, one thing that I wish that we had explored a little bit more were both their opinions on sort of this idea that Zaki introduced last episode that I know you're very curious about, is this idea of like the minimum viable stack. And it was useful, I think, to hear Dave talk about the Cosmos SDK. And on the one hand, he's obviously very technical and in the weeds, and Osmosis, to my understanding, is actually a core contributor to the Cosmos SDK as well. It seems very powerful today. On the other hand, I love the way that Dave closed things, which is to say, question everything, right? We're still so far from the end state. So I guess my question to you is, how did you think differently now, hearing the way they talked about the minimum viable stack? And I've got a question for you on sort of network effects that accrue to that. But what did you think about that whole part of the conversation?
I think that's the other piece of this. I mean, we've really only seen the Cosmos SDK in action in terms of app chain stacks out there, and I think that somebody who's been in the space like Dave for a long time and has built a lot of that stack, and he'll be the first one to tell you there are a lot of shortcomings with it still, and so that leaves room for more of these stacks to evolve, and maybe we'll borrow pieces from the Cosmos stack that make their bootstrapping experience a lot easier, right? Because we can get into the network effects, but I think I view the success of these stacks and really the ecosystems that use them as a combination of I'd say ease of developer onboarding and how easy is it for existing apps to migrate to your stack. I would say what is the quality of the ecosystem that's already using that stack, so sort of a biz dev component, and I think all the other stuff that we talked about is important too, like what are the costs involved with using these different stacks, and so there's a lot more to come out. I think we'll see different modular stacks on the Celestia that leverage Celestia, kind of like as we mentioned, sovereign SDK. I think we'll see L3 stacks like the OP stack that Optimism is building, or what Slush is building for the Starknet ZK rollup ecosystem. And yeah, I think it will really be interesting to see what sort of applications migrate to these different new competitors based off of what capabilities they offer.
We sort of closed on this idea of MEV, and the reason we did that was because our next episode, we're going to be talking a lot about how MEV functions in Cosmos. Can you just give for the listeners, why are we dedicating kind of an episode to MEV? How does that sort of play into the app chain thesis that we're
Yeah, I think when we talk, this whole season is about, owning your own block space and what can you do with your own block space? How can you leverage, that to make your product better? And I think MEV plays into this in a couple different ways, because MEV is really getting at, right, how do you extract value by ordering transactions in a certain way? And I think by owning your own block space, you can be extremely opinionated about how those blocks are constructed, and you can do so in a way that, one, protects the user against harmful MEV. So these are things like, somebody detecting your transaction in the mempool and then, inserting their transaction above yours to say, or above yours and behind yours to sandwich you. This, at the same time, you can basically harness this control over block space to capture the value of the MEV yourself, right? And so, to me, I think this is one of the most compelling, I'd say, tailwinds of the Appchain thesis, is that you can have the best of both worlds as it relates to MEV. You can improve the user experience by protecting them, right, from harmful MEV. And you can also improve the amount of value capture that your application can extract from your block space, which then can be, right, reinvested into the product again. Or it can be, you can leverage this, value accrual to undercut competitors with more rent-seeking value accrual methods like fees. And so I think, it's going to be an important dynamic here, and I'm excited to get into it more next week.
Me too. One thing that you were already on this before we started the season, but one thing I've really changed my mind about, or was just wrong, frankly, about, is that I thought a lot of the reason for launching your own app chain was to be able to capture more economics of MEV, whereas really, even listening to like Dave, it's more about what you can do with your product and what you can get your validators to do for you. That being said, I do think that one of the reasons I'm particularly interested to dig into MEV in the context of Cosmos is there's sort of this almost repeat. A lot of the ideas I'm realizing, another takeaway for me from the season thus far, a lot of what you see in Ethereum's roadmap actually popped up in Cosmos first in some ways. Like lazy. So Celestia is a great example of that. They were, in 2019, the white paper was Lazy Ledger, right? And they were sort of the first ones to really advocate for this idea of modularity, which is now broadly accepted by the Ethereum community and baked into their roadmap. But, one question that I have that we started to get into a little bit in this episode is what are the dynamics of MEV in a modular architecture going to be, right? Because in when there aren't different layers in the stack, there's just MEV that gets captured by sort of the base layer. But then, when you layer on different, in a layer 2 context, right, there's a sequencer that captures some of the MEV before the transaction ultimately ends up getting routed and settled on the base layer chain. And then on top of that, even there's in a third layer, right, there's the app chain, right, which is the app chain, I would assume, right? And I'm sure Dave and Sunny would want to capture a lot of the MEV on the app chain layer as well. So, I think within that context, one idea that I want to explore a little bit is, I think, again, in the Ethereum side of things, they sort of view these rollups, generalized layer 2 rollups and roll-apps on top of that as benevolent extensions of Ethereum mainnet interest, in which in a lot of ways it is, but in a lot of other ways, it's actually, you're sort of competing for value capture and margin along that chain as well. So just an idea that I would introduce.
Yeah, absolutely. And I think we'll get into it next week, but just how much can these shared sequencers do in terms of, that value capture, and how much of that flows back to the application, is a big question for me. And how much control does the application, have over how that value is distributed? I think that's a big question. And, I think we'll see one thing that I think we'll see on Cosmos first before it appears on Ethereum is some of the more interesting on-chain solutions for MEV. So this is, moving something like Flashbot's off-chain auction to actually be on-chain, right? Where it's completely verifiable and open source, and also, gives the chain control over how that revenue is distributed, right? You're not trusting the validators to kick back some portion to just stakers, right? Maybe it goes to users, maybe it goes to investors in another sense. But yeah, I think there's plenty to unpack here, and we'll get into it more next week.
All right, Miles, this has been a fun one. I will see you here for our MEV episode next week.